if you click on the link in the main body of the unit, this is the website that is pulled up. And what it is showing is 3 waves. There is a red one, which you can see, a white one, which you can see, and there is also a blue one, which you can't see, but which I can make appear. Now you can see the blue one. The white one, you notice, if I pause this, is the sum between the red and the blue one. So whenever they line up perfectly, the white one is as big as possible. And there's also a time when the white one goes through 0 when they're lined up opposite of each other, if that makes sense. So there they're getting close to being opposite. I don't think I can advance it forward on its own. Right. Okay. So there are several things we want to look at. The first question is, what happens when these 2 waves are in phase? When they are in phase, let's see what I can do to make this happen here. And let's stack them. Okay. So now I've just slowed one down. Okay, and we can move it here. This will allow me to pause easily. When it grows to be as big as possible, which is about here, the waves are in phase. And what it means to be in phase is that crest lines up with crest everywhere and trough lines up with trough everywhere. Those 2 then sum to give you as big a wave as possible, and this is known as constructive interference. On the other hand, if we let it advance slowly, they move out of phase until there's a point where they're virtually perfectly out of phase. Notice the trough of the red one lines up with the peak of the blue one, and those 2 add together to give 0. It looks like there's no wave, even though there are these 2 moving through. This is what is known as out of phase and results in destructive interference. Now, there's other things you can do. If I shift the wavelength of one relative to the other, I get this kind of ebb and flow thing. Here I've got a big amplitude because they're more or less in phase, but then there's this other spot where they're more out of phase, and so it gives more of a smaller wave, and it moves back and forth. I can make this more apparent if I play. Aha! Here you can see constructive interference happening, then it moves through a region where there's destructive interference, then constructive, then destructive. If this were sound, it would sound like wah, 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 where it gets loud and then it quiets down, and then it gets loud and it quiets down. If you play an instrument, you would know this as a beat frequency. And again, it occurs when your waves have just slightly different wavelengths. If I increase the difference between the wavelengths, that effect gets quicker and quicker and quicker and quicker until you can't hear it. Similar if I go the other way, quicker and quicker and quicker until you can't hear it. The closer they are to being together, the longer the beat frequency is, which is why you can use beat frequencies for determining whether 2 instruments are in tune to each other, tuned to each other.